Atlas LO2 fill and drain valve cycle test is complete.
Roger.
Atlas Airborne vent valve functional test complete.
Roger. Perform pogo suppressor charge.
Roger.
All sequences are complete through 4.151.
T-minus 25 minutes.
This is Atlas Launch Control, T-minus 24 minutes and counting. We are approximately 34 minutes away from the launch of the JUNO spacecraft on the Atlas V. And at this time, we are not working any technical issues on the Atlas V. JUNO is also in the final activities to prepare it for flight, and they are not working any issues as well. The weather is go. The forecast has essentially not changed, and we are looking at an on-time liftoff at 11:34. Once we lift off, we'll be tracking the vehicle through several different means during its powered flight. We'll begin first with our tracking station here at Cape Canaveral, which will take it from liftoff through about 7 minutes and 10 seconds, and in addition, about 40 seconds after liftoff, an Air Force range tracking station located down near Jupiter Inlet will also acquire, and between the station here at the Cape and the Jupiter Inlet station, will have coverage from the ground for about 7 minutes and 20 seconds. At that point, we will be ready to transition to the Antigua tracking station, which will be acquiring just prior to loss of signal from the Florida mainland. And they will be able to track the rocket until 11 minutes and 48 seconds, until which time the tracking and data relay satellite will be able to provide coverage up until spacecraft separation. And as well, we will be getting video from the Dongara tracking station in Western Australia. We'll get that about 48.5 minutes into the flight. And after spacecraft separation, about 5 minutes after separation occurs at 58 minutes 49 seconds, the Deep Space Network at Canberra tracking station will also be acquiring JUNO now at that point on its own. At T-minus 21 minutes 35 seconds and counting, this is Atlas Launch Control.
Roger.
T-minus 19 minutes.
Perform RD-180 transducer converter calibration.
Roger.
T-minus 18 minutes.
BRCU, SIB1 and SIB2 voltage checks are complete.
Roger.
RD-180 transducer converter calibration complete.
Roger.
T-minus 17 minutes.
Engine fuel inlet valve is closed. Roger.
T-minus 16 minutes.
Initiate fuel fill sequence. Roger.
This is Atlas Launch Control, T-minus 15 minutes, 30 seconds and counting. Loading liquid hydrogen now onto the Centaur stage. In about another 6 or 7 minutes, we'll get an update on the weather forecast from Air Force Launch Weather Officer Clay Flynn from the 45th Weather Squadron. And as far as our programming, the Centaur's first burn will cut off at 10 minutes 45 seconds into the flight, and at that point we will be entering a 31-minute coast phase, and during that time we will be running our launch replays from the different cameras around the Cape and downrange on our long-range trackers. At T-minus 14 minutes 38 seconds and counting, this is Atlas Launch Control.
LC step 4.160, FTS open test complete.
Roger. All steps through 4.160 are complete.
T-minus 12 minutes.
LC, Redline Monitor.
Go ahead.
Yes, about 1 minute ago, approximately T-minus 13 minutes. Measurement Echo Golf Alpha, 885 Papa. That's ambient branch pressure, went OTC low. The lower limit's 2545. It's currently reading 2562, so it's back in range, but it dropped below the lower limit briefly.
Roger, understand. ALC, LC.
ALC.
Roger. It's reporting a momentary drop of the booster ambient purge pressure below the op limit of 2545 psig. Please convene the anomaly team and provide a recommendation.
Roger. Anomaly team to net 6. Target set TS underscore 4235-01.0 and primary adjust tech hex file adjust underscore alpha victor 029 underscore 07 with SDL CRC 1 Bravo 35 has been received, verified, and loaded into the FTI new.
Roger.
This is the LWO with the L-20 weather brief. You should have a satellite picture of the east central Florida peninsula on your CCTV monitor. And you know we have some cumulus cloud development out over the central Florida area. More cumulus clouds just north of the pad. Weather One is assessing those. Tops on those are really only about 5,000 feet high. Not an issue for any type of fly-through cumulus cloud. Not really expecting to violate the cumulus cloud rule through the balance of the count. Just a small threat of any additional development that would breach the +5. In terms of taking a look at the radar, no showers on the radar that are threatening. You can see a shower out there about 60 miles to the east-southeast, drifting towards the west-northwest, but it'll pose no threat for us during the window. In terms of the winds out at Complex 41, winds still relatively light. Had a few gusts up in the teens, but for the most part 10 to 12 knots. We should pick up just a little bit more, but still would not expect to see gusts greater than 16 knots during the window. Winds at the present time are from the south, and they should become a little more southerly to south-southeasterly if we go into the window. In terms of the temperature at the present time, it's 88 degrees, and that's about where we should stay, maybe drop a degree if the winds turn. In terms of the upper air profile, this is HR 1, 2, and 3 in the 50 megahertz. Good, not expecting significant change in the profile through the count. In terms of the ops forecast, no change from earlier other than I adjusted the cloud cover for the actual height, scattered at 2,400, scattered at 28,007 miles visibility. Winds from the south at 12, gusting to 16 with isolated showers developing along the sea breeze, but that should be west of the coast area. 87 to 88 and a 20% chance of violation, and that's principally concerned with any type of cumulus clouds that would continue to develop. No change in the 24-hour forecast, no change in the 48-hour forecast. Small threat of any type of lightning during the window, and proton flux remains or continues to trend down slightly, and we'll continue to monitor that. This concludes the weather brief pending your questions, sir.
LC, this is Redline Monitor on 1.
Go ahead.
Yes, that OTC Echo Golf Alpha 885 Papa is back in band. I'm wondering if I can clear that OTC.
Roger, proceed.
Roger.
Switch all secondary DCOMs to RF link.
Roger.
NASA IE. This is the NLM on the NLM net. Be advised.
T-minus 6 minutes.
Fuel fill sequence is complete.
Roger.
T-minus 5 minutes.
Start lowest data acquisition.
Roger.
Atlas LO2 at flight level.
Roger.
Centaur LO2 at flight level.
Roger.
Centaur LH2 at flight level.
Roger.
This is Atlas Launch Control, standing by now to go into our hold at T-minus 4 minutes. It's a 10-minute hold. In 5, 4, 3, 2, 1. T-minus 4 minutes.
T-minus 4 minutes and holding.
10
this
minutes.
is a program 10-minute hold.
And in just about a minute, we should
All
hear our
switch to channel
NASA
1.
launch director
All
come up and provide us with a launch status. And everyone will be switching to the communications countdown main channel, what we call channel 1, launch conductor's channel, at this time. T-minus 4 minutes and holding. This is Atlas Launch Control.
Verify the FCO, RCO, and OSM hold fire switches are in their proceed position.
Ready to proceed.
Perform launch on time verification.
Roger.
DTP status verified.
LCSC.
Go ahead.
SMD is standing by on channel 1 for comm check.
Roger. SMD, this is LC on channel 1 for a comm check.
This is SMD on channel 1. I hear you loud and clear. Do you copy me?
Roger, have you loud and clear also.
NLM,
Copy
NASA
that.
CE on the NLM net.
LC step 4.176. DTP status verified.
Roger.
Go ahead, NASA.
Yeah, just want to verify if you have any questions from the discussion on anomaly.
NLM, we're still looking into something here. So stand by a moment. Okay.
Apply onboard video power.
Roger.
LCAC.
Go ahead.
Roger. I'd like to bring up another issue. Apparently we're seeing some higher than normal charge cycles on the center helium system. So prior to out-briefing the ambient branch pressure, which is not a concern at this time, we'd like to go back to channel 6 and discuss the higher rate of charge cycles on the anomaly net.
Roger, I understand. Please convene the anomaly team. Launch Director, LC.
LD on 1.
Roger. LD, at this time, the anomaly team is going to be active discussing an anomaly issue regarding the charge cycles. At this time, I would recommend holding off taking the spacecraft to internal and standing by at this L-9 point.
LD concurs.
Roger.
This is Atlas Launch Control, T-minus 4 minutes in holding. We're working a couple of what appear to be minor issues at this point on the Atlas, but need to be resolved. So the decision has been made to hold off taking the spacecraft to internal power. Our NASA launch director, Omar Baez, has advised Jan Chodas, the spacecraft project manager, that the recommendation is to hold off taking the spacecraft to internal power. That does mean that we will not be making the opening of the window at 11:34, but we still have plenty of time to address these issues to be sure that we're comfortable to fly. So right now we're at T-minus 4 minutes in holding. We will extend the hold an additional 5 minutes is the current plan, while we work on a couple of issues that are under discussion to assure that we are good to fly today. At T-minus 4 minutes on holding, this is Atlas Launch Control.
LC, LD channel 1.
Go ahead.
Please extend the hold an additional 5 minutes.
Roger. Com, LC.
Scama 1.
Roger. Extend the current hold an additional 5 minutes.
Roger.
This is Atlas Launch Control, T-minus 4 minutes in holding. The launch team is evaluating an issue on the Centaur helium system, and they're talking about that. They're comparing what they're seeing on the Centaur helium system with what was seen during the countdown, wet countdown dress rehearsal, which is a fully fueled, tanked practice countdown of the vehicle, and trying to compare what we see here with that. They're also checking to see if the ground side of this system, as well as what's going on the flight side, is something that we recognize, and they'll also be doing a leak check. So at any rate, we're going to be extending the hold while we evaluate the state of health of the Centaur helium system. Now, once that can be isolated and determined, we will pick up and resume the countdown. So we'll be monitoring several measurements over the next several minutes to determine the state of health of the Centaur helium system. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Launch Director, LC.
LC, LD on channel 1.
Roger. Recommend extending the current hold an additional 5 minutes.
Please proceed.
Com, LC.
Scama 1.
Roger. Extend the current hold an additional 5 minutes.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. Right now we are evaluating the charge cycles of the helium system on the Centaur stage. And what we're doing is to bump the countdown in 5-minute increments. The spacecraft is not on internal power. They have maintained it on external power until this issue is resolved, and then when we go to pick up the countdown, they'll be going to internal at around launch minus 9 minutes. At T-minus 4 minutes and holding, this is Atlas Launch Control. This is Atlas Launch Control, T-minus 4 minutes and holding. The test team has decided to run a test on the Centaur helium system that will take about 5 minutes to complete. In the meantime, they'll stop flowing cryogenics to the Centaur to get some data associated with the charge cycles on the Centaur that have to do with the
Launch Director,
steering,
LC on channel 1.
gimbling of the steering system.
Extending the current hold an additional 10 minutes.
Roger, proceed.
Roger. LC.
Scama 1.
Roger. Extend the current hold an additional 10 minutes.
Roger. 10 minutes.
LCAC.
Go ahead.
Roger. Prepared to provide you an interim brief on the higher than normal Centaur helium charge cycles.
Proceed.
Roger. The team would like to recommend that we place the helium charge system into a stop flow condition. The operator can do this from his schematic. Purpose of this is to lock the system up and try to determine whether or not we have a leak in the system, identify the source. And we'd like for it to stay in a locked up condition for a duration of minutes. And during the lockup test, there are 3 measurements that we will monitor. On the ground side, Michael Fox Lima 515 Papa. On the airborne side, Charlie Foxtrot Echo 002 Papa. And we'll also look at bottle mass, Golf Foxtrot Quebec 000 Michael. And again, duration of this test would be for 5 minutes. And we'll evaluate the data and resume our anomaly discussion on 6.
Roger. Understand and concur. NASA Launch Manager.
NLM understand and concurs.
Roger. And Launch Director.
Launch Director copies and concurs.
Roger. Centaur Pneumatics, LC.
Go ahead.
Roger. You prepared to stop flow on the helium charge system at this point and perform a lockup for 5 minutes?
Yes, sir.
Roger. Proceed.
So as we heard, they will embark on this test, which will take about 5 minutes to complete, and then they'll take some time to discuss it, and then we'll see where we are. T-minus 4 minutes and holding. This is Atlas Launch Control.
LCAC.
Go ahead.
Roger, I'm prepared to provide you an outbrief regarding the earlier issue on the ambient branch pressure limit violation.
Roger. Proceed.
Roger. As reported by Redline Monitor, we did have a slight violation of the backup measurement, Echo Golf Alpha 885 Papa, which is the ambient branch pressure, which provides pressure to the RD-180 high flow purge. Team evaluated this. We see no issues going forward. The primary measurement did stay in band. Apparently the system was set a little bit lower than nominal, but still well within the operational limit. We don't expect to see any additional issues during terminal count. They will see another load on the system at approximately 20 seconds, but that load is not nearly as great as the branch flow experienced at the time of the violation. So recommendation from the team is to proceed.
Roger. Understand and concur. NASA Launch Manager.
NLM copies and concurs.
Roger. And Launch Director.
LD copies and concurs.
Roger.
LCAC.
Go ahead.
Roger. Be advised, we believe we've isolated the source of the leak to be on the ground side. We've asked Centaur Pneumatics to terminate the test so that we do not bleed the system down too far. So they have terminated and they are resuming their charge cycles. And we'll provide a final out brief here momentarily.
Roger. Centaur Pneumatics, LC.
Go ahead, sir.
Roger. So understand you are back in a nominal charging configuration?
That is correct.
Roger. And is flight mass still maintained at this point?
Yes, sir. We're well above minimal.
Roger.
LC, Range Coordinator 1.
Go ahead.
LC at this time, range is no-go due to fouled SCO. We have choppers out re-sweeping the area.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. The testing that has been underway indicates that the issue with the charge cycles on the Centaur helium system is on the ground side, on the ground support equipment. It's not on the vehicle. So now they are talking about what they can do to maintain the proper level of helium flow and cycling up through a T0, knowing that the vehicle does not have a problem, but there's some things that they need to do to get comfortable with that. So that is still under discussion. Other than that, the only other thing we're working, as we heard, is there's a boat in the box, in the launch danger box, so that is now being dealt with. And Range Safety is sending their Range Safety helicopters out there to attempt to move the boat out of the launch danger area. So right now a couple of issues still under discussion, but we're cautiously hopeful that we'll be launching within the window still at this point. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Launch Director, LC. Com, LC.
It's Com 01.
Roger, extend the current hold an additional 5 minutes.
Roger, 5 minutes.
LCLD's on, copy that.
Roger.
LCAC.
Go ahead.
Roger, sir. I'm prepared to provide you with a final out brief regarding the higher than normal charge cycles.
Roger, proceed.
Roger. We believe we've isolated the problem to the ground side based on the lockup test. As a precautionary measure, we would like to have the operator switch the vent valve system to the secondary mode using option 360. This is a standard operating procedure. We could be experiencing some bleed through on the primary valve. Either way, recommendation would be to switch to the secondary mode and continue with the launch countdown.
Roger. And we would do that switch prior to terminal count?
The sooner the better.
Roger. Understand. And the anomaly team recommendation is to proceed with terminal count?
That is affirmative.
Roger. LC copies and concurs. NASA Launch Manager?
NLM copies and concurs.
Roger. And Launch Director?
Copy and concur.
Roger. Centaur Pneumatics, LC?
Go ahead, sir.
Roger. Please switch your helium charge system to the secondary mode using option 360.
Roger, will go.
And advise when complete.
Copy that.
Launch Director, LC?
LDN1.
Roger. At this time, launch vehicle is ready to proceed with terminal count, just awaiting your direction for a new T0.
Roger. All issues are resolved, and we are standing by here on SCO box.
Roger.
LC, the helium bottle vent valve is switched to secondary.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. As we've heard, we've cleared our technical issue, and the only thing remaining is to hear from the range that there are no remaining boats in the launch danger area, and as soon as the range gives us a green, then we will determine our new T0 time and continue on down toward a launch today. We still have about 39 minutes remaining in our launch window. At T-minus 4 minutes and holding, this is Atlas Launch Control.
Launch Director, LC?
Go ahead, LC.
Roger. At this time, recommend extending the hold an additional 5 minutes.
Copy and concur.
Roger. Com, LC?
Com on 1.
Roger. Extend the current hold an additional 5 minutes.
Roger, and work.
LC, LD, Channel 1.
Go ahead.
This time, LC, please put into work a target of a new T0 of 1613 Zulu.
Roger. Copy 16:13 Zulu.
Good copy.
Roger. Range coordinator, LC.
LC range coordinator 1, go ahead.
Roger. Please coordinate a new T0 of 16:13 Zulu.
Roger, 1613 ZN work.
Roger. Com, LC.
It's comma 1.
Roger. Please set the countdown clock for a new T0 of 16:13 Zulu.
Roger, 16:13 Zulu.
This is Atlas Launch Control, T-minus 4 minutes in holding. As we've heard, adjusting for the time they give as Greenwich time, our new T0 is going to be 12:13 p.m. Eastern Time, assuming that the range can give us a clear to launch by that time. And we should be getting a poll from the NASA Launch Manager in just about 1 minute. And the only issue now is waiting for a range clear to launch.
This is the NLM on the NLM net for our final launch poll, and ready to release the hold at T-minus 4 minutes. Currently working to a T0 of 1613 Zulu. NASA CE. NASA CE, this is the NLM on the NLM net. NASA CE, this is the NLM on the NLM net.
NLM, this is CE2. Net 4, CE is likely still engaged in the anomaly discussion. I recommend we delay this poll as far as possible.
Okay.
NLM NASA CE on your net.
Go ahead, NASA CE.
I heard you were calling.
Yes, sir. We were polling to release the hold at T-minus 4 minutes. You ready to go?
No, we're still working this item.
Still working an item.
Correct. Yeah, so no, we are not ready to come out of the hold.
I copy. No go.
Okay, as we heard, NASA Engineering is still discussing the circumstances and is not ready to give a go for launch yet.
Our switches are in the proceed position.
Ready to proceed.
Roger.
The range very shortly will be able to give us a go.
LC, LD, channel 1.
Go ahead, LD.
Please extend the hold additional 5 minutes.
Roger. Com, LC.
SCOMA 1.
Roger. Please extend the current hold an additional 5 minutes.
Roger, 5 minutes.
This is Atlas Launch Control, T-minus 4 minutes and holding. With that an additional 5 minutes extension, that would put our liftoff time at 12:18. And basically the anomaly discussions just simply did not finish in time to be able to give a go to make the 12:13 launch time, but those discussions are wrapping up. And so 12:18 appears that is probably going to be our new launch time. We'll stand by for confirmation of that. And at T-minus 4 minutes and holding, this is Atlas Launch Control.
LCAC.
Go ahead.
Roger. There was extensive discussion on the engineering net to ensure that we understood the ramifications of the leak on the ground side to make sure that it wasn't going to have any negative repercussions. This was not held as an anomaly discussion, just as an engineering evaluation. The team has determined that we have plenty of margin and that with Redline Monitor protecting us, that we are ready to proceed.
Roger.
No issues.
Roger, understand. Launch Director, LC.
Launch Director on 1.
Roger, standing by for direction on a new T0.
Roger, LC, at this point the booster vehicle is cleared for flight.
That's affirmative.
No issues are being worked.
That's affirmative.
Roger, stand by for new direction.
We're still at T-minus 4 minutes and holding. Confirmation that the range has given a go, that the boats in the area are now out of the launch danger area. And it's appearing that we may extend once again to give the NASA and associated engineering teams time to reach a firm conclusion on the issues that we've been working. They're getting very close to that. Meanwhile, the JUNO spacecraft remains on external power. Appears we may be going toward a 12:25 liftoff now, but that's not confirmed.
Go ahead.
LC, please put into work a new T0 targeted for 1625 Zulu. 1625 Zulu.
Roger, copy 16:25 Zulu.
Good copy.
Roger. Range coordinator, LC.
LC, range coordinator 1.
Roger. Please coordinate a new T0 of 16:25 Zulu.
Roger, 16:25 Zulu, in work.
Com, LC.
It's comma 1.
Roger. Please set the countdown clock for a new T0 of 16:25 Zulu.
Roger, 16:25 Zulu.
And there we have our confirmation that 12:25 is our new launch time.
LC Range Coordinator 1.
Go ahead.
New T0 1625 Zulu has been coordinated and approved.
Roger. All stations maintain your readiness to support of T0 of 16:25 Zulu.
Comp check channel 1.
Read you loud and clear.
Hold to launch to remove the hold at T-minus 4 minutes. NASA CE.
NASA CE is go.
SMM.
SMM is go.
SMD.
SMD is go for final count.
SMA.
SMA is go.
NAM.
NASA advisory team is ready.
Copy that.
And that's our final poll from Omar Baez, the NASA launch director, that he'll pass along to United Launch Alliance that NASA is ready to proceed. Again, we're targeting a 12:25 launch time.
NSC, LC on channel 1.
Go ahead.
Spacecraft to internal power.
Roger.
Flight control, LC.
Go ahead.
Configure Centaur main vehicle battery heaters for launch.
Roger.
And we're standing by now to pick up the countdown. Approximately 15 seconds, we should be resuming.
Centaur main vehicle battery heaters are configured for launch.
Roger.
They're resetting the countdown clocks here in the Launch Control Center to make the final
Red line monitor
adjustment.
and event table are in the correct configuration for terminal count.
Roger. All steps prior to the status check are complete.
That would put us about 7 minutes from launch. And Spacecraft Project Manager Jan Chodas has just confirmed to NASA Launch Manager Omar Baez
Status
that
check
JUNO
to proceed
is
with terminal
go
count.
for launch.
Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
OSM.
Go.
ULA safety officer.
Go.
Range, weather, and final clear to launch.
Go. LC, LD, channel 1.
Go ahead.
LC, you have permission to launch.
Roger. Proceeding with the count.
LC, NSE on 1.
Go ahead.
JUNO is on internal power.
Roger.
And we should be about 2 minutes now from picking up the countdown.
T0 is planned for 16:25 Zulu. Set count to start at 16:21 Zulu.
Roger. T0 is set for 16:25 Zulu. Count will start at 16:21 Zulu.
Now our clocks are in sync. We should be picking up the count in about 90 seconds. And we'll pick up now in 1 minute. "30 seconds from picking up the count.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
3:55.
Ground pyros enabled.
Headed for a launch time of 12:25.
Three minutes.
Securing LO2 topping.
Atlas takes to flight pressure. 250.
Yep, just internal.
2 minutes.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
T minus 25 seconds. We'll get the final go from both Atlas and Centaur. Flight termination system is armed.
$120.
Orca's armed.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valves locked.
T minus 1 minute and counting.
$49.
T minus 45 seconds.
Stable at step 3.
T minus 30 seconds.
25.
ECS reduced for launch.
Roger. Status check.
Go Atlas. Go Centaur.
20.
T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
Our roll program is in progress. Vehicle body rates look good. Booster PU has gone to fixed angle, show confirmed. SRB chamber pressures have plateaued, I'm rolling off, signatures look good. RD-180 operation looks excellent at this point in the flight. Mach 1. SRB chambers continue to roll off. Max Q. Boosters throttling up, right on schedule. Engine response looks good. Booster Pu's gone to closed loop control. Looking for our SRB throttle down momentarily. Engine continues to operate well. And booster has throttled back. Looking for SRB burnout soon. Chamber pressures have plateaued on the SRBs. And we're beginning to roll off. And BOTA has been satisfied. Vehicle is throttling back up to full thrust. And we have solids 1, 2, 3, 4, and 5 jettisoned. Visual indication that all solids have separated well. And the booster has begun its roll for spacecraft thermal constraints. Rates look good. Bus and battery voltages are stable. And the vehicle has now gone into closed loop steering. And booster PU is also in closed loop control. Engine response looks good for the set mixed ratio. Current altitude is 45.8 miles in altitude. Downrange distance 69 miles. Velocity 5,413 miles per hour. Coming up on our RCS pyro valve activation. It is now fired. System's now pressurizing to flight levels. We've begun our 2.5 G throttle segment. Engine response looks good. Current altitude is 60 miles in altitude, downrange distance 118 miles. Velocity is 6,983 miles per hour. Coming up on our next mark event will be payload fairing jettison, followed by the CFR jettison. And we have payload fairing jettison and CFR jettison. Boosters throttled back up to full thrust. Engine response looks good. Now accelerating at 4.7 Gs as we work our way to our 5G throttle segment. Boost phase cooldown is underway. Now throttling to maintain 5 Gs. Pogo pyro vent has been fired. And begun throttling to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. We have BECO, engine shutdown looks good. We have retros and stage separation. We have LOX and fuel pre-start. RCS-GN2 purge firing is underway. We have ignition and full thrust on the RL-10. Centaur closed loop steering has been enabled. Small body rates associated with closed loop steering. Vehicle tank pressures are being ramped down as expected. Centaur PU has been commanded to oxidizer-rich fixed angles for the early part of this 6-minute and 2-second burn. Current altitude is 112 miles. Downrange distance is 589 miles. Velocity is 14,318 miles per hour. Range track shows the vehicle right down the middle of the corridor, making excellent progress. Centaur tank pressures are very good at this point, holding expected levels. Storage bottle pressures are as expected. Bus and battery voltages look good.
Just acquiring the signal.
And we're seeing our phase 1 thermal conditioning firings on the RCS. Line temperatures look good. Centaur is now operating in closed-loop PU control. However, it continues to request an oxidizer-rich condition as it works off the excess oxidizer. Our RL-10 engine operation looks good as we have a momentary loss of data. Right where the format change is supposed to happen. And we have resumed Centaur telemetry. At this point, the MDU format change should have occurred.
Also signal here at the Cape and Jupiter Inlet. Antigua now with data.
The RL-10 continues to operate very well. Current altitude is 134 miles. Downrange distance is 1,081 miles. And current velocity is 15,339 miles per hour. And we're seeing another RCS thermal conditioning firing as the line temperatures warm towards bottle temperature. Signatures look good. Centaur continues to request an oxidizer-rich condition. With a little over 2 minutes remaining in this burn, all Centaur systems look nominal. RCS line temperatures have now warmed to bottle temperatures as expected. RL-10 continues to operate well in an oxidizer-rich condition. Centaur mass error is approximately 500 pounds. One minute to MECO. All Centaur systems continue to look excellent. And we have IAP vanish coming up on MECO momentarily. And we have MECO. Engine shutdown looks good. We have 4S settling on. RF has been disabled. Rob, can you give me orbits? I've got to pull up that screen. And Centaur has begun its turn to its PTC attitude. During the PTC roll, it'll be rolling at 3 degrees per second. Fuel tanks have been vented down, and we continue to settle in a 4S mode. And Centaur has now achieved the 3 degree per second roll rate for the PTC and continues its slow turn to its PTC attitude. Rob, it was expected to be 104 by 121.2.
Data now coming through the tracking data relay satellite. We've had loss of signal at Antigua.
Quick check of the orbit shows that Centaur is exactly where we wanted it to be.
With the cutoff of the Centaur and
Centaur has begun venting the fuel tank down to condition propellants during the coast phase.
with the Centaur now going into the coast phase, it's a 31-minute coast phase that began with the cutoff of the Centaur engines. Centaur will restart 41 minutes 33 seconds into the mission for a second 9-minute burn. So while we're in the coast phase, we're going to look now at some of the replays of the launch from the different angles around Kennedy Space Center, Cape Canaveral Air Force Station, and our long-range trackers.
All Centaur systems continue to look very stable as the PTC attitude change continues. And Centaur has completed its orientation to the PTC attitude during the coast phase. All systems continue to look excellent. And Centaur has begun to ramp the 4S settling motors to a 25% duty cycle. Signatures look good. All Centaur systems continue to look good. Data quality is very good at this point in the mission as we continue to ramp down to the 25% duty cycle on the RCS. We're now 10 minutes into our 30-minute coast between MECO 1 and MES 2. All systems continue to look good as the RCS continues its ramp down to 25% duty cycle. And Centaur has now achieved the 25% duty cycle on the RCS. All systems are stable. Helium storage bottle pressures look good. Bus and battery voltages are stable. Centaur is now halfway through its 30-minute coast, continues to roll at 3 degrees per second in its PTC attitude. RCS is operating at a 25% duty cycle. Tank pressures are stable. Storage bottle pressures are as well. Bus and battery voltages look good. And we have had our LO2 LOX duct flush. Signatures look good. Centaur has now begun its PTC roll reversal. And Centaur has completed its PTC roll reversal. It's now rolling at minus 3 degrees per second. Centaur is now 2/3 of the way through its 30-minute coast period. Continues to roll at -3 degrees per second in its PTC attitude. RCS continues to operate at 25% duty cycle. All Centaur systems are operating nominally at this point in the flight. Telemetry data quality continues to look pretty good with some minor interruptions. In about 30 seconds, we expect to see Centaur begin its turn to MES 2 attitude and begin 50% duty cycles on the RCS. And Centaur has begun to reorient to the MES 2 attitude, and RCS is now operating at a 50% duty cycle in preparation for MES 2. 5 minutes to MES 2. We are experiencing some data dropouts associated with the PTC roll and the turn to MES 2 attitude, but all systems continue to operate well. And Centaur has begun 4S settling, and it's also begun to despin from its PTC roll.